Welcome to ETM 260 Computer Aided Design. This is Lecture 9, Assembly Tools, Part 2. Let's start with a description of the top-down assembly design approach. In this approach, the user has the ability to create components in the assembly environment. Each of these components will be saved with its own file name. The advantage of this approach is that the user has the ability of using the dimensions of the components that are previously used. This is very useful when the objects have very complex curvatures and dimensions. Let's now learn how to create new component in an assembly file. Go to Open, Lecture 9, Part 1. And this is a file that I already created in an assembly environment. Go to the Assemblies tab and click on Create New. A new window will show. Notice that at this part we could choose to create either a model or a new assembly. We're gonna go for model, click OK. A new window will show. At this moment you get the choice of designing if you want to use defining objects such as tangent planes, tangent axis, so on and so forth. You're going to add the new name that you would like to have. So let's see, Part 1. You want to have it as a reference set, either as a model or as an entire part only. If you select model, it will be only the solid. However, if you select the entire part only, we'll do the solid plus things like axis and tangent planes. So that's the one that we're gonna choose. We're gonna select the origin of the component. Either we select a new coordinate system or we use the absolute 0. So we're gonna go for absolute 0. And then we're gonna click OK. Notice that as you do that, if you go to the assembly navigator, you have created a new model. If you want to start building that model, simply double click on it. Notice that the piston will go into like a ghost mode. And if you go now to the part navigator, you see that the tangent plane system is hidden, so we could just simply show it by right click and say show. And now it shows up. Now what we could do is simply start the sketching process. Go back to home. And at this moment, you will follow the steps that we already know to sketch the part using this environment. The difference is that once you create this part, you could then save it as the name that you had given it when you created. It will be saved in the same location where the original assembly file was created. We're now gonna learn how to create sub-assemblies and how to use them in NX. The advantage of having sub-assemblies is that you could create a feature that is repeated multiple times, and you could save it as a file and then simply import it and use it in the main assembly. So we are going to see the sub-assembly shown in Figure A, and we're going to use it so that we could regenerate and create Figure C. I have already created the sub-assembly, so please go and open Sub-Assembly 1. This sub-assembly has the articulation rod, has the piston, it has the different rings, it has a plug, and it has the pins. Please, in your own time, create this sub-assembly. Before we go into the assembly file, let me show you how I changed the color in the components of the assembly. You go into the View tab and then go into Edit Object Display. You select the object that you want to change and then you say OK. Notice that a new window will show. You could click in here and change the color that you would like to use. Let's see, we want this. You could also, if you want, change the translucency of that particular object. Once you're done with your selection, you press OK. Once you have created the subassembly, make sure that you save it properly. We're now going to create the main assembly using the subassembly. Let's go to File, New, and then we're going to select Assembly and then click OK. We're going to start by opening the master rod. Since this is the first part that we're going to use, we're going to use absolute origin again, and then we're going to click 0. Since this is our first part, we are going to use the fixed constraint. We're going to go to Assemblies, Assembly Constraints, and select Fix to ensure that this part does not move. This part now is going to have the pin, the plugs, and all the components that are going to here. But I'm going to show you how to use and how to constrain the sub-assemblies first. So let's add the component. We're going to select the sub-assembly part 1. And then we're going to select the origin. The idea is that the subassembly is going to go into each one of the components over here. So let's constrain it. We're going to do assembly constraint. We're going to do touch align infer axis between this hole and this hole over here. We're now going to be able to move it so that we could continue the constraining process. Notice that it rotates. We would like to center this rod between the two sections inside of the master rod. So the way that we're going to do is assembly constraint, center. Since we have two surfaces for the articulation rod and two surfaces for the master rod, we're going to use center 2 to 2. So select the upper surface, select the bottom surface, select the upper surface, and select the bottom surface. Now it's aligned and is centered. Let's see how it looks. This subassembly now has the freedom only to rotate about this axis. Notice that if we try to rotate it, it should only be able to rotate in this way. It should not be able to go up or side to side. We would like now to fix the angle between this master rod and the pin. So let's go to the top view so that we could see it better. Notice that what we want to do is have an angle between the master rod and the link. We are not sure about the angle of this surface, if it's parallel to the actual center of the link. So what we need to do is utilize the Danton planes of this particular figures. The way that we need to do that is to convert this model into an entire part. The way that you will do it, select the part, right click, and notice that it says reference, replace reference set. At this time is model, which means that it only shows you the solid. If we want to see all the other features associated with it, things like axis or dantums, we go into entire part. Now notice that we have it, and we're gonna do the same thing with the articulation rod. Let's go back to the top view, and notice that what we want is we want to create an angle between this Danton plane and this other Danton plane. Following the constraints given on the textbook, there is an angle between this datum plane and this one of 75 degrees. So we're going to the isometric view. We are going to assembly constraints, and we're going to use angle. We're going to select this datum plane and this datum plane, and then we're going to have an angle. So let's look from the top to see how it's done. So since we know that it's going to be 180 minus 75 to indicate the angle that is given in that particular direction. And then once you're happy with your selection, press OK. At this moment, you could repeat the same process by adding the subassembly at this location, and this location. Notice that for this part, you need to add the piston, the pin, the plugs, and the rings. Please take the time to complete this assembly, since this is one of the tutorials from your textbook. We're now going to learn how to create exploded views. To do so, open the file Subassembly 2. This assembly has the articulation rod, the piston pin, and the piston pin plugs. We would like to create an exploded view which will show you the relationship between the components and how they are related to each other. To do so, go to the Assemblies tab, go to Exploded View, and create New Explosion. At this moment, it will ask you for a name. We're just going to use the default name, Explosion 1. There are two methods that you could use to create an explosion, automatic or manual. Let's start with automatic. I'm going to go Exploded Views, Auto Explode, and we're going to select the components that we would like to explode. If you want to do all, simply select all by clicking on this icon. Click OK. The auto explode will give you a distance by which an X will separate each one of the components by. Let's say 100, and click OK. And then let's zoom out so we can see it. So notice that not all the times the auto explode is the best method. Notice that it separated the pin from the articulation rod, but it didn't do for the plugs. This moment you could edit the view by going into Edit Explosion and do it manually. We're going to select the objects that we're going to have. So let's see, I'm going to have this piston, plug, and I'm going to move it. I always recommend that you use the axes that are given to do your motion so that you could keep the relationship between the components. So let's see, I'm only going to move it down using the y-axis so that it's very strong like this. I would like to move this piston a little bit lower so that you could see the relationships. Notice that at this moment we have an exploded view that shows us all the components separate from each other, and it still keeps a relationship of how they work. You can tell that this pin goes inside of this hole over here. You can tell the plug goes into here, and the plug eventually goes into a component that goes into this hole. And that is the whole point of exploded views, to be able to see the components and the relationship between them. This is the end of Lecture 9, Assembly Tools, Part 2. Make sure to complete all the required quizzes, review the material in the given PowerPoint and Chapter 10 from your textbook, and be ready to start class assignments.